Take a look at this Async Rust web server. It's handling thousands of requests per second. It's blazingly fast. Just assume that where we have a process payment API where multiple thousands of users calling this API, and we have in that API we have something like thread, uh, thread sleep and time. Um, from second, 1 second, and yeah. So if we add this line, not only we are freezing our server, and also other endpoints that don't even use this code are suddenly timing out. So what just happened? Welcome to the async Rust performance, where blocking the executor, where threadship is blocking our executor. So today we are looking at the three most common ways developer accidentally ruin their async code and exactly how to detect and fix them. So let's debug. Async Rust uses cooperative multitasking under the hood. An executor like Tokio runs multiple async tasks on a small pool of threads. When a task hits an dot await, it yields control back to the thread, saying, I'm waiting for data, go work on another task. But look at what happens when you use standard library sleep. When you call standard library thread sleep function, you are not putting the task to sleep. You are putting the entire OS worker thread to sleep. The executor is completely hijacked. If you only have four worker threads and four users hit this endpoint, your entire application is dead in the water. So how do we fix it? Instead of using standard library thread sleep function, we'll use Tokio time sleep function where so first let's implement Tokio time sleep function. So also we have to avoid it. So now you might be wondering what's the difference between Tokyo time and standard library thread sleep time function. The only difference is standard library thread function blocks the entire OS thread, whereas Tokyo time sleep only blocks this specific future. And if you don't know what futures are similar to what promises in JavaScript. But JavaScript promises are eager, whereas Rust futures are lazy. Okay, now you know not to slip a thread, but what if you need to do heavy computation, say hashing password, parsing giant JSON files, or calculating primes? So let's look at this example where even though this function is marked async, there are no await points inside that massive loop. It never yields control. The Tokyo thread is trapped doing math, ignoring all other incoming web requests. If you so if you have heavy CPU bound work, you must offload it using Tokyo task spawn blocking. This moves the heavy work to a dedicated pool of background threads, keeping your async executor fast and responsive. So now let's implement Tokyo spawn blocking function, and now we'll move this line of code inside here, and we'll print our result. It's giving an error. So let's look at that. Uh, okay, we are not returning our sum function, sum variable. So let's return that. Yeah, and let's also format this. Format, yeah. Now it looks better. Yeah. Now let's look at our final example, which is which mutex should you use in Async Rust. And this one actually start a fight in Reddit also. The standard library one or Tokio Async Mutex. A lot of beginners think I'm in async, I must use async mutex, and that's actually a wrong assumption. Tokyo's own documentation tells you to use standard sync mutex by default. But wait, as you can see from example, we are using uh, sync mutex. So now you might be wondering that we are using a sync mutex, which blocks the thread. Yes, but locking a standard mutex is so incredibly fast, often just a few CPU instructions, that it doesn't matter unless you do this. If you lock standard mutex and then await a database query, you have taken the lock to sleep with you. Other tasks that need that lock will now freeze. The executor threads trying to get it. The Rust compiler will usually yell at you for this, but if you hack around it, you will destroy your app. So to fix this, to fix this, to to actually fix this, we have already used sync mutex for fast and simple state updates. But if you absolutely must hold a lock while waiting for the network database across n.await point, that is when you use Tokyo Sync Mutex. So how do you know if your code base is secretly suffering from these blocking issues? You are not just going to guess. You need to use Tokyo Console. It's an incredible diagnostic tool built specifically for this. It gives you a top-like dashboard for a async task. If a task is hogging the CPU and starving the executor, Tokyo Console will literally flag it in red and show you a busy time that is way too high. You can also use Tokyo block and space function in some scenarios, but simply turning on tracing and hooking, Tokyo Console will reveal your bottlenecks instantly. Async Rust gives you incredible performance, but it is a team sport. Your task must cooperate. So, so here's the three things you must keep in mind. First thing is never use standard library thread sleep function. And second thing is offload heavy math computation to spawn blocking of Tokyo function. And third thing is never hold a standard mutex across an .await. If this video saved your production server, you can like and subscribe to our channel. And yeah, that's it for this video. Thank you.